Hi friends, today I am going to explain one of the line drawing algorithm, that is the midpoint line drawing algorithm. In last two videos of unit 2 in computer graphics, so we will discuss about the DDA algorithm and Bresenham's algorithm. So basically these two algorithms are depends on the two important concept. So that is one is starting and ending coordinates of the given for drawing the line, and the next one we will find the number of coordinates. Here also the midpoint also takes the two criteria here. The first one is it will start the line drawing algorithm to given the starting and ending coordinates, and the second one is it also finds the number of intermediation coordinates in between the starting and ending coordinates. This midpoint algorithm attempts to generate to the number of intermediation coordinates in between the starting and ending point. So here is the procedure somewhat changes compared to the DDA algorithm and Bresenham's algorithm. So now we make it observe the difference between these two. In the DDA algorithm we will find the slope value, and in the Bresenham's algorithm, so we will find the decision parameter pk value. But here we will take the initial decision parameter d initial. So in the place of parameter pk, here we can find the initial decision parameter, that is the d initial, and one more here content will be find, that is the delta d. And similarly here also the next parameter also finds with notation of d new. Here is the few changes are taken in this algorithm compared to the Bresenham's and DDA. So this algorithm is also a popular line drawing algorithm, and also which is also accurate compared to the previous algorithms, because of here we can find the initial parameter value and also the new parameter value, that is the d new. Now coming to the procedure. So I already explained the two important concepts are taking this procedure before it takes the implementation. The first one is the starting and ending coordinates are taken, and the next one we will find the number of coordinates in between the starting and ending coordinates. Now we go through the taken of the starting coordinates, that is the x0 y0, and ending coordinate xn and yn. So now the ending coordinates are taking the differential values of y coordinates, and the starting coordinates also taking the differential of x coordinate, that we can take in the delta x and delta y, where delta x equals to xn minus x0 and delta y equals to yn minus y0. Now we can imagine. So this is the procedure which we will find out one of the notation delta x and delta y is similar of the DDA and Bresenham's algorithm, and here we will find the initial decision parameter d initial equals to 2 delta y minus delta x, and delta d equals to 2 into delta y minus delta x. You can see the difference between these two, because d initial equals to 2 delta y minus delta x, delta d is the 2 is the common factor of delta y minus delta x. So you make it identify the difference between the d initial and the delta d value. So here in the previous we can find the decision parameter pk, and here we can find the d initial value and the delta d value. In the first DDA algorithm we will find the slope value m. So you make it identify the changes in between the DDA and the Bresenham's and this particular midpoint algorithm. Next one, similarly here the next coordinates are finds with the help of the depends on the d initial value. So the d initial is the initial decision parameter. So d initial, it also defines the two more condition. So the midpoint algorithm derived the two cases, the case 1 and case 2. Here is the depends on the value of d initial value, that is the decision parameter value, initial decision parameter value d initial. So now coming to the case 1, in the case 1 is nothing but d initial is less than 0. So the first condition is less than 0, then the next coordinates will be taken xk plus 1 equals to xk plus 1, yk plus 1 equals to yk, and the next decision parameter d nu. Here you can observe the d nu is the next parameter, d nu equals to d initial plus 2 into delta y. So this is the case 1 you can observe. So in this case 1, so we have to find out, here you can observe the next coordinates are like xk plus 1 and yk plus 1, and the d nu value is d nu equals to d initial plus 2 into delta y. So these three values are calculated based on the values of the initial coordinate xk and yk, and already we find the d initial value, d initial equals to 2 into delta y minus delta x. So the second case is, here the second case is based on the d initial value is greater than or equals to 0. Here two conditions are applicable, either greater value or equal value. So d initial is greater than or equals to 0. The next parameters we will find xk plus 1 equals to xk plus 1, yk plus 1 equals to yk plus 1, and the d nu value equals to d initial plus delta d value. So d initial plus delta d value, this is the case 2. Now based on the d initial value we will find the next parameters, next coordinates, and the d nu value. Now you just compared why we have to take this process is compared to the Bresenham's algorithm and the DDA algorithm, because this is the procedure, basic procedure to design the line drawing algorithm with two cases. So we will find the new decision parameter. Based on that, some of the drawing algorithm can be taken the efficient manner. The efficient manner in the sense the immediate coordinate will be taken the exact value. So the midpoint algorithm defines that to take the notations in between the starting and ending point. So the intermediation coordinates are defined very efficient manner compared to the previous two. Now here also the two cases are derived. One is the d initial value less than 0 and the d initial value greater than or equals to 0. Now these two conditions are taken. Now coming to this, coming to this fourth step, now you can observe this third step is repeating until the last point is reached. In every algorithm you can observe either the DDA or Bresenham's algorithm and this algorithm. So the third step after the condition is over, so we need to find the next coordinate and the next coordinate. So until the last coordinate is reached. So the process will continue. That means every time we take the d initial value, again next time we will find the d nu value. Again in the next cases the d nu value becomes to the d initial value, and again we will find the d nu value, and so on. This process continues until the last point is reached. Here the d nu value depends on again the two more cases with based on the decision parameter value. Now coming to this, go to the practical example. So before we go to the practical example, so we need to understand these algorithms of some of the criteria. The first one, the given coordinates are the common and the x0, y0 and x and yn, and we can find the delta x value and the delta y value. So after finding these two value, again we go for the initial decision parameter, that is the d initial equals to 2 into delta y minus delta x. And similarly we can find the delta d value. Delta d value is nothing but differential values of the parameter. Here this is the new identification compared to the previous two algorithm. So the differential of the decision parameter delta d equals to 2 into delta y minus delta x, that we have to observe in this particular notation. And coming to this practical example, so we will find the next coordinates with based on the d initial value. Here the given coordinates are the 20, 10 and the ending coordinates are 30, 18. So now you can observe the initial and ending coordinates, and again we will find the delta d value, delta x value and delta y value. So where delta x equals to xn minus x naught, 30 minus 20, 10 value, delta y equals to yn minus y naught, that equals to 18 minus 10, that equals to 8. So coming to the d initial value and delta d value is calculated. D initial value equals to 2 into delta y minus delta x, which equals to 2 into 8 minus 10, which equals to 6 value. And delta d value equals to here 2 of delta y minus delta x. Delta y minus delta x in the sense 8 minus 10, that is minus 2 into 2, that equals to minus 4. So delta d value is minus 4. And coming to the third step, as d initial is greater than or equals to 0. Why? Because already d initial value we can calculate, that is the 6 value. Now that value is greater than or equals to 0, we go to the second case. In that second case, what is the next parameter value? Xk plus 1 equals to xk plus 1, yk equals to yk plus 1. If the second case, that is a positive value, both values are incremented. X value and y value both are the incremented. That is, the x value becomes to the 21, y value becomes to the 11. So the d new equals to d initial plus delta d. So this is the one more d new value we can find. Already d initial value is taken. That is the, what is the d initial value? That is 6, and delta d value is minus 4. So what is the d new value? That is 2. So we will find the d new value. We will find the next coordinates of x and y. That is the xk plus 1 and yk plus 1. So these values are, after deriving these values, now you make it absurd. This is the tabular form. We can derive the number of coordinates in between the starting and ending points. Now you may be observed in every time. So we will find the d new value. So when we take the d initial is the value which can be derived the next initial value. So the next initial value, next new value is taken the next starting initial point of the d initial. So you can observe here there is no ambiguity. You clearly understand what this concept is. Actually, this is the d initial value and this is the d new value. Now the d new value becomes to the d initial value, and based on the d initial value we will calculate the d new value minus 2. Again the minus 2 is taken here is the d initial value, and we will calculate the next initial parameter value and here. And similarly we can calculate the next coordinates. Initial coordinates are the and 20, 10 next coordinate, because if it is a positive value, every time the x and y coordinates are incremented. Here you can observe incremented. In every time the x and y coordinates are the incremented value. If it is negative value, here the minus 2 is there. In the negative value, only the x coordinate is changes, the y coordinate is the common. That is the yk is similar to the yk. So this is the case you can observe. If the positive values, the next coordinate xk plus 1, yk plus 1 is incremented. If the negative value, so the xk value is only incremented, the yk value is the same. And we will continue see here until the last coordinates are found. What the last coordinates given? That is 30, 18. So this is the given coordinates of the last coordinates. So until we will continue this procedure until the last coordinates are reached. So finally we can derive the graph with based on these values. So here you take the x coordinates are the x axis and y coordinates are the y axis, and we can draw the diagram like this. So we take the values of the based on the given coordinate value. So the range is 0, 5, 10, 15, 20, 30, 35 and so on. So because here based on the interval values we can set it this particular differences on the x coordinate and similarly the y coordinate. So this is the midpoint algorithm. This algorithm is mainly focused on the new decision parameter d new value, and based on the d initial value. D initial value we can calculate it from the delta x and delta y, and based on the d new value we can calculate the based on the d initial value we can calculate the d new value, that is the new decision parameter. And similarly here also calculated the x coordinate and y coordinates, and similarly the next coordinates of the x and y coordinates. So we will continue until the last coordinate is reached. Now you can observe these three algorithms, either DDA or the Bresenham's algorithm or the midpoint algorithms. These three algorithms should follow the two important notations only. One is it will be started with the help of the starting and ending coordinates, and also these three algorithms will find the next coordinates, that is an important one. So the next coordinates, how many coordinates are derived in between the starting and ending, there is a big question, that one. So in the DDA algorithm, the number of iterations are derived with the help of the absolute value of x and absolute value of y. In the Bresenham's algorithm, what the number of iterations are derived, that is the delta x minus 1. Here is, there is no point of view that the intermediation device how many iterations are derived, because the new value is changes rapidly. That's why based on the given intervals only, based on the given intervals in the sense based on the given starting point, ending point only, we can calculate the number of iterations. That is the midpoint line drawing algorithm.